So, before I start this lesson, I am going to tell you a quick story that I know you don't care about, but I'm going to tell it anyway. So, this afternoon, I was in my classroom and I recorded this nice lesson. It was really good. Saved it, uploaded it to YouTube, and I was like, oh, I'll post it to Google Classroom later because I was running out of time. And I left. So, about 15 minutes ago, I went to go upload it to Google Classroom, and I thought to myself, man, I should probably make sure this video works, I'm going to hit play on it. And I'm glad I freaking did, because it had no sound. So there would have been nothing for you guys to watch, which you might not have cared about, but you also wouldn't have learned anything. So I proceeded to be super PO'd about the fact that it had no sound, whatever. I was I accepted the fact that I just got to re-record it, move on with my life. So I proceed to re-record. I got 10 minutes into the lesson, and when I had gone back to delete stuff so I could write again, I freaking deleted half of the examples. Probably because it's 10:30 at night and I'm supposed to be in bed. So anyway, this is my third attempt at this, and I am super tired. I do not feel good, and I just don't care anymore. So I'm going to kind of speed this up. Please feel free to pause it, and if you need anything, come prepared with questions on Friday, and I'll be more than happy to answer anything that you didn't get from this video. Also, I didn't bring my little pen thing home, so I have to use my finger to write on this iPad, and it probably is going to suck, so I'm sorry about that too. So, on to the lesson. This is 3.4 and is on composition of functions. So, before we get into composition of functions, we're just going to talk about how to do operations within functions. So, functions has been our focus this chapter. And a function is just how you relate a set of numbers to each other. Usually it's x squared plus 2, or it's an equation type thing, but it doesn't have to be. It could just be a random picture, but that's not important. Anyway, so when we're doing functions, operations within functions, you can add them, subtract them, multiply them, or divide them. So if you want to add them, depending on how it writes it, you're just taking, if it says f plus g of x, you're going to take f of x plus g of x. If it says f minus g of x, you're going to take f of x minus g of x. If it says multiply, you're going to take f of x times g of x. And then dividing f of g divided by x is going to be f of x divided by g of x. So we're going to do some examples within operations. So on our first example, it says find and simplify g minus f of x and then do the division g of f of x. So it says given f of x to be x minus 1 and g of x to be x squared minus 1, do the operation. So from above, it says if you have g minus f of x, that means you can take g of x minus f of x. Well, I know my g of x function is equal to x squared minus 1, so I'm just going to sub that in for g of x. And then for f of x, I know that f of x is equal to x minus 1. So I'm going to sub that in for f of x. When you do subtraction of a binomial, you have to distribute your negative. So I'm going to go ahead and solve this. So I get x squared minus 1 minus x plus 1. So then I go through and I simplify. Well, plus 1 and minus 1, they cancel, and you're just left with x squared minus x, and that is your answer. So now we're going to come down and do the division. So we would want to do g of x minus f of x. So again, we're just substituting. Well, g of x is x squared minus 1. So we're going to sub that in for it. And f of x is x minus 1. So we're going to sub that in for that. Well, if you know, the top is a difference of squares. So it factors into x plus 1, x minus 1, all over the quantity x minus 1. Well, there's an x minus 1 on top and an x minus 1 on the bottom. So my answer is x plus 1. Okay, we're going to do 2 more examples. So in the first example, it says find f times g. So f times g of x is the same thing. Sorry, those do not look like parentheses. That's because I'm using my stupid finger. Can you tell I'm really irritated? F of x times g of x. So f of x is x minus 1. So we're going to sub that in for that. And then g of x we know to be x squared minus 1. So we're going to sub that in for that. We have a binomial times a binomial, so you're going to have to FOIL. So I take x times x, and that gives me x cubed. I'm sorry, I said x times x. X times x squared gives me x cubed. X times negative 1 is negative x. Negative 1 times x squared is negative x squared. Negative 1 times negative 1 is positive 1. Just simplify it, like putting it in standard form. So x cubed minus x squared minus x plus 1. And that is your answer. Make sure, I forgot to mention this, because I did in my last 2 lessons. When you're doing subtraction, you have to make sure that if it says f minus g, that the f function goes first. And if you do g minus f, the g function has to go first. Subtraction is not commutative, meaning that the order does matter. So if it has a g first, the g has to go first. So we're going to do f minus g on this one. So that means we're doing f of x first, which is x minus 1, minus g of x, which is x squared minus 1. So we're going to distribute our negative. So this gives me x minus 1 minus x squared plus 1. Well, those cancel. So I'm left with negative x squared plus x. Well, if you look, so f minus g of x gives us negative x squared plus x. But when we did the reverse of that, we got x squared minus x. So see, those answers are not the same thing. Okay? This answer in green is not the same answer as the answer in purple up there. So just know that when you're doing subtraction, you have to make sure the order matters. It doesn't matter so much when you're doing addition, because addition is commutative. Subtraction is not, so it does make a difference. Okay, so now we're going to go into compositions. So compositions is just taking 2 functions and combining them into one. So we write that as f with a little circle, g of x, which is f of g of x. And we write it as f parentheses g of x parentheses. You can do g of f of x too if you wanted, so you can reverse that. But essentially, what you're doing is we're used to seeing like f of x. So what we're doing is instead of x, we have a g of x in there, which means we're going to take whatever our f function is, and we're going to plug in the g function in for that. So it's going to be like plugging in an equation into another equation. Okay? So on the first example, it says find f of g of x if f of x is 2x plus 1. I'm sorry, just dropped my iPad. And g of x is 3 minus x. So, I'm sorry. We start with the f function. So f of x equals 2x plus 1. And what we're trying to do is f of g of x. So what we've done in the problem we want to find is we have substituted in the g of x function in for the x function in the f function. So that's what we're going to do on this side. Wherever there's an x, we're going to plug in the g function. So 3 minus x. And then you're just going to simplify. So 2 times 3 is 6. 2 times negative x is negative 2x. And then plus 1. And then 6 plus 1 is 7. So 7 minus 2x or negative 2x plus 7, however you want to write it. That would be up to you. So you're putting, since the g of x function is in where normally we have an x, we're going to put the g of x function in where we normally have an x in the f function. So let's try another one. They've redefined f of x. This time they say it's the square root of x plus 2, and then g of x is x squared plus 3. So for the first one, we're doing f of g of x. So normally we're going to start with f of x because that's what's on the outside. And f of x is the square root of x, and then outside of that plus 2. We'll see the g of x is in the position of the x. So that means over here, wherever there's an x, we're going to put the g of x function in. So x squared plus 3, and then plus 2 on the outside. So this was essentially where x was. So that's all you're doing. If you can simplify it, simplify it. In this case, you can't. I mean, you probably could, but we're not going to. We're just going to leave it like that. So the second one reverses it. This time we want to do g of f of x. So this time we start with the g function. Well, the g of x function is x squared plus 3. And so we're going to take f of x and we're plugging it in for the x value. Okay? So wherever there's an x, we're going to put like a set of parentheses, and then we're putting the f function in. Well, the f function is the square root of x plus 2. You could simplify that by foiling pretty easily. I am not going to do that. I would not require you to do that. If it's something easy to simplify, simplify it. If it's not easy, just leave it. We are going to skip this whole thing. When I recorded it the second time, I skipped this example anyway. I should have skipped it when we did the first example, or the first time I did this. It's irrelevant, and I don't make you do any problems on it, so don't worry. Okay, example 5 says, using a table, we're going to evaluate a composition function. So the first function we're going to do is f of g of 3. So this is a little different from what we've been doing because instead of g of x, it's telling us what g of 3 is. So when you do these, you work from the inside out. So first we're going to find g of 3. Well, if you are struggling with functions, g of 3 means it means the g function at x equals 3. Okay? So to find g of 3, I need to find what the g function is at at 3. So here, this row is x equals 3. So we go to the g column, and we see that the answer is 2. So the g function at x equals 3 is 2. Well, now, in our f of g of 3, we know what g of 3 is. We know it's 2. So we're going to put 2 in for this. So now it's going to be f of 2. Because we know what g of 3 is, we're just substituting in that value. So now, based off of functions, we know this is the f function at x equals 2. So we go to x equals 2, and the f function is 8. So f of 2 is 8. So that has gotten us to our final answer. So f of g of 3 is 8. We're going to do the second one. So the second one wants us to do g of f of 3. So again, we're working inside out. So first we're going to find f of 3. So that's the f function when x is 3. I want the f function. Well, the f function is 3 at x equals 3. So now I know what f of 3 is, so I'm going to plug that in. I know the answer for f of 3 is 3. So now I'm going to find g of 3. That's the g function at x equals 3. So we're in the same column, but this time we're looking at the g. And the g answer is 2. So for g of f of 3, the answer is 2. And I really hope that you guys are understanding this. It's hard, like when I record these lessons for you guys, because I can't feed, I don't know what your faces look like, and I don't know if you have questions. If you have any questions, Mr. Rush would be a great person to help you. He knows a lot about functions because we do this in Algebra 2. If not, just wait and I will help you guys when I get back on Friday. Okay, we have just a couple more examples. So now we're going to use a graph to evaluate the composition. So instead of them giving me a table, they're giving me a graph. So to do f of g of 1, you start in the inside and we're going to find g of 1 first. So that means I need the g function. So I'm looking at this graph. So this is the g function when x equals 1. So essentially what you're looking for is the y. What is the y value when g is 1, or when x is 1? So if you look up here at x equals 1, the graph touches right there at 3. So g of 1 is 3. Well, now since we know what g of 1 is, we're going to sub that in for g of 1, and we're going to find f of 3. So this is the f function. So now we're on this graph at when x equals 3. So we're going to x is 3. See what the y value is? Our y value is 6. So the answer to this problem, f of g of 1 is 6. Alright, I want to say that, great news, I have 3 examples left. Praise Jesus. Okay, so f of t is t squared minus t, and h of x is 3x plus 2. It doesn't matter that one's in t's and one is in x's. That doesn't make a difference. Don't worry about this. I guess I didn't erase all of this. My bad. Sorry. So it wants us to find f of h of 1, h of f of 2, and h of f of negative 2. So to find f of h of 1, so this is basically what we've been doing in the last 2 examples, but in the last 2 examples, they gave me either a table or a graph. Here they're giving me the functions, and I've got to evaluate. So you start in the inside, and you do h of 1. So we do h of 1 first. Well, h's function, h of x, is 3x plus 2. So what we're going to do is we're going to plug in 1 for the x, because we're saying this is the h function when x equals 1. So what is the h function when x equals 1? Well, it's 3 times 1 plus 2. So that's 3 plus 2, which is 5. Again, I know you guys don't give a crap about this, but I swear my neighbor just, went to go put her trash can at the curb. She scared the living poo out of me because I thought someone was trying to break in my house. Sorry. This is the worst video ever. I'm sorry, I suck. So now that we know, so when we're doing f of h of 1, I know h of 1. It's 5. So I'm going to plug 5 in for that. So now I'm going to find f of 5. So this is the f function, which is t squared minus t, when t is 5. And it doesn't matter that in the last one we had x's and now we have t's. That's okay. So we have 5 squared minus 5. That's 25 minus 5, which is 20. So f of h of 1 is 20. And there's your answer. I did this earlier too. Don't just think it's because this is my 3rd time recording it. I'm not going to do the last 2 examples to save a little bit of time because I know the homework's pretty lengthy and I want you to get it done in class if you can. But if you go to page, I think 215, I actually have 0 idea if that's correct. But I'm really hoping it is. If you go to page 215, you will be able to see the last 2 examples if you want to see them. It is in fact 215. I'm sorry, I was looking for that. Okay, last thing we're talking about is decomposing a function. So we just talked about composing a function and making a composition of 2 functions, which in composing them, we took 2 functions and we put them together. So to decompose, we're going to take them apart. So they're going to give you a function, and then they're going to say, all right, now separate this. So again, when we did compositions, you're given some f of x, you're given some g of x, and you write an h of x function by like combining them. Here you're going to start at h of x and you're going to work your way backwards, okay? There's really not a great way to explain how to do these other than the fact that you're like looking for something kind of random and seeing how you could basically replace a piece of the function by just putting in an x value, essentially. So the first example I'm going to do is f of x is the square root of 5 minus x squared. So I want to rewrite this as two functions, okay? So, like, underneath the radical, if I could take this whole part out, actually, I'm going to do that. Oh, it's not going to let me. If I could take that whole part out and rewrite that as, like, a new function, h of x, then what I would be left with under the radical is just x. Because, remember, when you do a composition, you're plugging this in for the x value. So I can take that piece out, make it its own function, and then substitute the piece that I took out with just an x. And so that's how you write your two functions for that one. It's one way to do it. You could have done probably something else, I'm sure, but this is the way we're doing it. So on the second set, I did this one for you guys on the board because in the homework it's kind of confusing on how they write the problems for these, like 22 through 26. I don't remember what the directions say, but you're just decomposing them. So see how this function kind of like stands out? I could rewrite this as 4 minus 3 minus x, and I could take that whole piece and put it into x. So I'm going to let h of x equal the square root of 4 plus x squared, and then that makes this whole portion my g of x, 4 over 3 minus x. And that shows that I can put that what's underneath that radical in for that x, and then it makes the f of x function. And that's how you check it. Like, can I plug in the one of the functions in for x and get the final function that I started with? Okay, last two examples, promise. I know I said that I only had one more thing left, but I had more examples. So, like on this one, since this is in a set of parentheses, big, I can't think of a word I'm trying to come up with right now, but like a big clue to you that you're like what to break up is if you have a set of parentheses, because if you go back to the examples I did, when I went to go plug something in for it, I put a set of parentheses around it, around where I would plug in an x. So if you see a set of parentheses, that's a big clue to you that that's one of your functions. So h of x is going to be x minus 3, and then g of x is then going to be just x cubed. Because what we're going to do is we're going to put a set of parentheses around that x, and that's how we plug in the x minus 3. Last one. Well, you could say to yourself, well, this one already has an x. So how do I write this x out? What if I just take this whole bottom part out and make it a function, and then this would become 3 over x. And there you go. So that's all I have for you. Hopefully you guys are okay. And if not, like I said, Mr. Rush is there, and he'll be more than willing to help you, I'm sure. You're doing 218. I know this is a lot of random stuff, but I tried to do my best and give you evens on some of it. So 5 through 16 evens, 22 through 25 all, 26 through 32 even, 42 through 78 even, and then 90 and 91. I do have access to emails, so if you need anything, please just let me know.